Okay, so we may know that this is the Behringer Wing soundboard, and we may even know how to use it to mix our audio. But how does that audio work? How do we get from this, a microphone, back to the soundboard? How does the signal travel so that we can mix it and then send it to the speakers? This is what we call a signal flow or signal path, and hopefully by the end of this video, you will be able to envision the signal flow. To help explain this, I've created a simplified overview of the equipment involved. It may not make sense to you right now because there are a lot of parts and a lot of equipment. We're going to start at the most familiar point, which is the soundboard. Then we will follow the signal path backwards to the microphone and then forward again in the correct signal path direction. So let's get started and take a look at this. This is the back of the soundboard. You've probably never seen this view, but back here is where all the signals come and go. We have inputs and outputs of various kinds, allowing us to control the entire system from one place. We're going to start with inputs. Inputs are well named. We take a device and plug it in to the soundboard, and then the audio from that device is now available to be mixed and altered. On the back of the wing, there are 8 mic inputs. These are where we could plug in microphones or instruments directly. We also have 8 auxiliary or aux inputs. These inputs work similarly to the mic inputs, but are more limited when it comes to mixing them and how we process those inputs. We also have 8 mic outputs that can go from the soundboard to the speakers or other audio destinations. And lastly, we have 8 auxiliary outputs, which are great for headphone or monitor listening to the mix. So, if we were in a small venue, we could plug 8 microphones into the local inputs on the back of this soundboard, mix them to our liking, and then output that mix to as many as 8 different speakers. You may be noticing, however, that, distance from the stage aside, there's a problem with this setup. We use way more than 8 or even 16 microphones and instruments. That is where our other equipment comes in. This piece of equipment is called a digital stage box, specifically the Midas DL32. As you can see from the image, it has 32 inputs and 16 outputs. This is one of the pieces of equipment that gives us so much flexibility in our system. This digital stage box lives on the stage tucked away and connects over a single Ethernet wire back to the soundboard. You can see that Ethernet wire symbolized here in red. This is what the stage box looks like in real life. It's all tucked in and mounted to a rack with all of the inputs being used, so everything from the stage is plugged into here. It looks kind of messy, but is handling all instrument and microphone signals from the stage all at once. Going back to some cleaned up images, you can see here a front and rear view of the stage box. Down here towards the bottom is the Ethernet port connection that makes connecting to the soundboard possible. This is called an AES50 port, and it allows for two-way communication between any other device that has an AES50 port. And surprise, we have 3 AES50 ports on the back of our wing soundboard. So now the soundboard can talk with the digital stage box over only one Ethernet cable. Because of this, where we used to have only 8 local inputs and 8 local outputs, now we get to have those inputs and outputs plus another 32 AES50 inputs and 16 AES50 outputs direct from the stage. So this stage box is able to share the signal of its inputs and outputs over AES50 connection all the way back to the soundboard. However, it is still difficult given the size of the stage to plug instruments or microphones directly into this stage box. That would mean that everyone would have to be close to the stage box so their cables could reach. We have our inputs, and we want to get a cable to those inputs on this stage box. This is where another piece of equipment comes in called floor boxes. Looking again at a portion of our signal flow diagram, you can see that the microphone is there and then it connects to a floor box, which then connects to the digital stage box. Floor boxes are a permanent installation in the floor of the stage. Each of them has 6 input connectors, and we have them spread across the stage. So you can plug instruments and microphones into these connectors, and then the box has a bundle of 6 wires coming out of the bottom of it that travel underneath the stage back to where our digital stage box is located. Each of these bundles pops back up from under the stage, and the cables plug into the digital stage box inputs. This keeps the stage clean, allows for inputs to be located across the entire stage instead of only at the digital stage box, and it protects the stage box itself. Here's a view of the stage with the floor boxes and where they are located. Over by the baby grand, we have inputs 1 through 5 mounted here directly into the floor. Then by the keyboard, we have inputs 6 through 11, and you can see that those are labeled. 12 through 17 are over here in another box, and you can see that in the blue tape, 17 is busted currently. And then 18 through 22 are over by the drum cage, and these are mounted directly into the floor as well. So a microphone or instrument plugs into the floor box, which then has 1 cable per input travel under the stage back to the digital stage box. The ends of these cables from the floor box plug into the respective digital stage box input based off of the numbers on the floor boxes. If this graphic were less basic, I would have included 4 more floor boxes, all sending cables carrying signal back to the digital stage box. Once again, here's a live view of our digital stage box. And you can see the cables from all of the floor boxes in white coming up from under the stage and plugging into their respective inputs. For things like the wireless vocal microphones, the handheld mic, the wireless pastor mic, we have the wireless receivers mounted directly above the digital stage box, and you can see the bundle of gray cables coming down from that rack and plugging into the digital stage box inputs, allowing for those wireless microphones to also send signal back to the soundboard. So the signal source plugs into the floor box, which then takes those signals individually over to the digital stage box at each respective input. If the acoustic is plugged into input number 6 on the floor box, then cable number 6 from that floor box will plug into input 6 on the stage box. The digital stage box then funnels all of those signals into 1 Ethernet cable and sends that out the back using the AES-50 port, which travels all the way through the walls and ceiling of the worship center until it pops back up at the soundboard. Here it plugs back into the soundboard using the soundboard's AES-50 ports, allowing every input and output on the digital stage box, which is 100 feet away, to effectively be treated as a local input and a local output and processed by the soundboard. Here's a live view of the back of the soundboard. You can see the AES-50 Ethernet cable plugged into its port down at the bottom. This one cable is what is allowing the board to speak with every other instrument and microphone that is on the stage and plugged into the digital stage box. Because the speakers are also closer to the stage than they are to the soundboard, we use the outputs from the digital stage box to send the fully mixed sound to the speakers. So to recap, the microphone or instrument sends signal from its cable into the floor box. The floor box carries the individual signals over individual cables under the stage and over to the digital stage box. The digital stage box then funnels those signals into 1 Ethernet cable, which carries them from the AES-50 port on its rear panel all the way to the soundboard. The soundboard processes each instrument and mic signal, which it then sends back over the Ethernet AES-50 cable to the digital stage box. The digital stage box, using its outputs, delivers that final ready-to-go mix to the speakers. So you may have noticed that we didn't talk about some of the other equipment that is included on this diagram, namely the Stream soundboard, Mac computer, Stream computer, and the in-ear stations. I'll be covering these things in the next video because those use a different digital signal than AES-50, which is called Dante, which offers its own strengths and uses. Hopefully this video was helpful in giving you the full perspective of the signal flow from the mics and instruments all the way to the speakers.